In this video, we'll be creating scatter plots. How to create a scatter plot? We need to label the axis, so we need to know what the information is about or what the graph is about. Create a scale. By looking at the set of data, we need to create a consistent scale for x and y axis. Then when we plot the points, we're going to notice a trend, assuming that the correlation or the trend is linear, in other words, shapes up in a close to a line formation. We can have a positive correlation if the trend of points is shaping from left to right upward. We can have a negative correlation if we have a downward direction, and no correlation if the points are completely scattered. Let's look at an example. We have a table that shows the study times and the test scores for a number of students. We need to create a scatter plot that corresponds to the given set of data. So I am going to use study time for the x-axis and then the test scores for the y-axis. So first, label the axis. So for x-axis, I choose to be study time, and for the y-axis, I label test scores. Then by looking at the study time, I have the biggest number 50. So by looking at the size or the value of the numbers, we need to create a scale that corresponds or it's reasonable for that set of data. So I'm going to go for 2 squares of my graph book, 10 from the origin, 10, then consistently up 10, 20, 30, 40, 50. And I don't need more than that. For the test scores, I have 84, the biggest number, so I can go from the origin and have a 10 per unit of the graph, consistently going up from the origin up 10, 20, 30, 40, 50, 60, 70, 80, and 90. Plot the points. So based on the created scale, now we have to plot the points. So for the study time, let's say 18 minutes, I have close to 20, stay on that 18, and the test score will be 60. So that is 1 point, 2262. So for the 22 minutes of study, the person had the score of 62. Then we had 2866. So for 28 minutes, we had a score of 66. Just estimate the point location. For 30, we have 67. For 34, we have 70. For 40 minutes, we have 76. For 48 minutes, we have 78. And 50 minutes, we have 84. So as you can notice, based on my plot or point location, we don't have a perfectly straight line, but the trend is upward if we were to follow this linear growth. So we have a upward direction that would be a positive correlation. So the last item that we would have to decide, it is a positive correlation. And what that means is, for generally, if students study for a longer time, their test scores tend to be better. So this is my conclusion that I'm going to record. The scatter plot represents a positive correlation And positive correlation, just like linear growth, is like a positive slope. And if I have to explain the meaning of this graph, I could say that students who spend more time studying tend to have better test scores. So when we're asked to explain the meaning of the graph, we can see that the more the student studies, the better is the test score. So positive correlation representing that students who spend more time studying tend to have better test scores. So this positive correlation, in addition to creating a scatter plot, we can add a line of the best fit. What that is a line that goes through the points, kind of like showing what the direction is and trying to have about equal amount of points above and below. So it's kind of eyeballing it a little bit to see where it goes through and show that positive growth. In addition to that, using the y-intercept or continuing this line, sometimes we can actually come up with a equation for the line of the best fit. So let's say without using exact information, I would say I can read that this is approximately maybe the slope 1/3. So I can say that it is a positive slope and the y-intercept will be at approximately 46. So if I am asked to estimate the line of the best fit and write its equation, it is a line that goes through the points in the graph or on the graph. We can just kind of try to have the equal amount of points above and below, and then by reading the slope and the y-intercept, we can come up with an equation. Let's see another example. This table shows study times in hours and the test scores for a number of students. So very similar example, but this time instead of minutes, we have this decimal numbers showing the study time in hours. Create a scatter plot that corresponds to the given data. So I'm going to use my study time again for x-axis and the test scores on y-axis. So first step that I have to do is label the axis. In other words, I have to tell what this graph is about. It's about study time and test scores. Then I have to look at the numbers, and I have 0.5, 1 hour, 0.75, 2 hours, 2.2, 2.5, 3 hours, 3.5. So I have the biggest number, 3.5, for the number of hours. So study time is given in hours this time. So I have from 0, I'm going to go 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. So I'm going to just go by whole hour. I can create a scale that goes 0.5, 1, 1.52, 2.53. As long as the scale is consistent, we can use it for the set of data, and it has to be reasonable for the numbers involved in the chart. Test scores going up to 97, so I'm going to go 10 from the origin up, 20, 30, 40, 50, 60, 70, 80, 90, and 100 up there. So make sure it's 50. Looks like I wrote 150 there. 10, 20, 30, 40, 50, 60, 70. So our study time, 0.5 or half hour, test score 35. So if you have a big test and you study only for half hour, that's not much at all. So the study time for half hour is 35, score. 1 hour, score of 40. 0.75, so I'm going back, so 0.75, again 40. 37, I'm sorry, 0.75, 37, close to 40. And then 2 hours is 62, 2 hours, score 62. 2.2 hours, score 70. 2.5, score 75. Right between 70 and 80. 3 hours, score 86. A little bit more than half. 3.5, score of 97. Well, based on this chart, that's the information that we have. Same conclusion. The more students spend, the more time students spend studying, the better test scores. So that is usually what the trend is. And this is the information from our chart. So it's not our opinion, it's the information from this particular chart. So the conclusion, we have positive correlation. And we can say that students who spend more time studying tend to have better test scores. Better scores. Now, if I was to create a line of the best fit, I have to kind of go through the points. So maybe just kind of have the equal amount before and or above and below. And it's always an estimate. It's not perfect, but it's the line of the best fit, right? The line of best fit will have the equation in slope-intercept form. Let me see some points here that I could read. Maybe it's really close to 1, but it's not quite. So I can use 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Like 8 sevens. X. So it's really, really close to 1 here if I look at the points. And then plus 20 for the y-intercept. Let's see another example. I have to create a scatter plot showing the hair color of students and the number of supplies they bring to school. Determine whether there is a positive, negative, or no correlation. Let's see here. We have not numbers, but actual hair colors in words. So we have the x-axis that I'm going to use for hair color. And the y-axis I'm going to use for number of supplies. All right, so I label my axis. Then I have to think about scale, what kind of scale I have. I can use the actual word for each mark. So I have blonde, black, dark brown, red, light brown, or I can give it a code. In other words, I can say maybe 1 for blonde, 2 for black, 3 for brown, 4 for red, and then 5 for light brown. So I can spell out those words there, or I can give them a code to mark so I know which is which. So I'm going to say 1 blonde, 2 black, the dark brown was 3, the red is 4, and mark them in the chart as well, just so you know what you used for what hair color. And then 5 light brown. In our graph, we need to come up with the scale for the y-axis, and we said that that's number of supplies. The biggest number being 8, I can just go 1, 2, 3, 4, 5 and go from the origin, or I can go by twos, 2, 4, 6, 8. So you decide what the scale can be better for you or how much space you have provided. I'm going to go from the origin up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then plot the points based on the information. I have 1 code for the blonde, number of supplies 5. 1, 5. People with black hair bring 2 supplies. People with dark brown hair, code 3, bring 8 supplies. Code 4, people with red hair bring 3 supplies. Next, light brown, code 5, 6 supplies. So by looking at my plot, I don't have a linear growth or linear trend. I just have points scattered all over the place. Well, that is no correlation because there is no relationship between hair color and number of supplies. I mean, that just doesn't happen that way. So for my conclusion, I'm going to say no correlation. And then for the explanation, I can say there is no relationship between hair color and number of supplies. All right. So as a reminder, what we have, and there is no line of the best fit here either because there is no correlation, so there is no trend to follow. So in order to create the scatter plot, remember what we have to do is make sure that we label the axis so we know what the x and y axis represent. we have to come up with a reasonable scale by looking at the numbers or the data from the chart provided. Then after we plot the points, we can notice trends, either up to the right positive, down to the right negative, or no correlation.